Hello, and welcome back to our course on Descriptive Data Analysis. In this course, we are studying different numeric measures that can be used to characterize and describe data. In this class, we are going to study summary measures, emphasizing the case of central tendency measures. The goal of the central tendency measures is to find one specific value that is the typical value of the variable or of the distribution. To illustrate the general idea, let's say that we have a basket full of apples, and we want to find a single apple that represents the whole basket of apples. This apple should have its features that somehow are the typical features of all the apples that are within that basket. This is the main idea of the central tendency measures, is to find one single measure that represents all the possible values of that specific variable. When we look at the descriptions that we have here, I am showing you different types of central tendency measures. The most common one is called the mean. Is simply calculated by summing all the possible values and then dividing by the number of samples that we have. This is the concept of the mean. The median, by contrast, is the central value of the possible values of the variable. And the way that we calculate it is by ordering all the values of the variable and taking the middle one. And if you have an even number of values, you just order them, take the two middle ones, sum them, and divide it by 2. This is the way that you calculate the median. The mode is the most frequent value. The mode is usually used for categorical variables. The midpoint is obtained by taking the two extremes of the data distribution, summing these two values, and divided by 2. The trimmed mean has a different philosophy. The idea is you calculate the mean of your distribution the same way that you do it here, and then you choose a number of values from each extreme, you remove these values, and then you recalculate the mean. And this is the so-called trimmed mean. And the reason why you do that is because when you order and you take the extremes, you may take extreme values. And the extreme values, they impact significantly the standard mean. The idea of the trimmed mean is to get rid of the extreme values so that you can calculate a typical value that better represents the distribution of your variable. We also have the mean of a frequency distribution that is calculated by taking the product of the frequency of each value times the value divided by the sum of the frequencies. And finally, we have the weighted average, and as the name implies, you calculate the average by weighting each value of the variable and then normalizing it by the sum of the weights. To illustrate how to calculate most of these central tendency measures, let's take the simple case of a variable that can assume the following values: 1, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 100. As we can see, we have the first value and the last value that are significantly different or distant from the other values in the sequence. Let's see how each of these measures look like. The mean is the simplest one. We basically sum everything and divide by the number of observations, which is 11. Then we have the mean of approximately 21.45. The median, we order the sequence and take the value in the middle. As we have an odd number here with a total of 11 numbers or 11 values, I can simply take the value number 6, which is 15. So the median for this variable is 15. This variable has no mode because there is no repetition, and the mode is the most frequent value. As every value occurs a single time or only once, then we have no mode. The midpoint is determined by taking the extremes, summing them, and divided by 2. So the midpoint is 50.5, and the trimmed mean, we can obtain it by removing part of the extremes. In this case, we decided to remove one single value from each extreme. So we removed 1 and we removed 100 from the sequence, and then we calculated the mean without these two values. And what we obtained was a value of approximately 15. By this very simple example, we can already observe some important characteristics of the different central tendency measures. For example, we can see that the mean and the midpoint are very sensitive to extreme values. And we also observe that if we remove the extreme values, as we did here to calculate the trim, and as we also do when we calculate the median, we get a value that better represents the typical value of the distribution. Let us now make a trade-off between the different central tendency measures that we studied. We are going to compare them based on their sensitivity to outliers, on their need or not to use all values to compute them, on their existence, and when we should use each one of them. As we observed in our previous example, the mean and the midpoint are very sensitive to outliers, and as the weighted mean is a small variation of the mean, it's also expected to be sensitive to outliers. The mean, the median, and the weighted mean, they use all values in the variable to be calculated, whilst the mode basically orders the variable or the distribution and takes the middle value. The midpoint considers only the extreme values, and the trimmed mean discards the extreme values to calculate the mean. The mean always exists, the median as well, and the mode not always exists, because if you don't have a value that is more frequent than the others, then you don't have a mode. This is exactly what happened with our previous example. In terms of when to use each one of them, the mean is usually applied when we have normal distributions and when we don't have extreme values or when we don't have outliers in our distribution. The median is very useful for skewed distributions and when we have extreme values. The mode is mainly applied to categorical data or when we need to find the most frequent value. The midpoint is when you want to find the middle point in the distribution. The weighted mean is when we have to attribute different weights for each value in my distribution, and the trimmed mean when we want to remove the extreme values before we calculate the mean. Now, consider the case of the histogram or the frequency distribution for the variable temp of the forest fires dataset. I plotted here the mean, the midpoint, and the median in this distribution, and there are some important features that we can observe here. For example, we can see that though this distribution is almost a normal distribution, it has a small tail to the left. And this small tail to the left makes that the midpoint is smaller than the mean, and that the median is greater than the mean as well. Right? So the relative positions of the mean, median, and midpoint give a good indication of the shape of our distribution. When we look at the frequency distribution of variable FFMC, we can see that it has a left skew, and this means that it has a left tail, and this tail is very long, and these are the values of the central tendency measures calculated for this variable. The mean is 90.64, the median is very close to the mean, 91.60, the midpoint is much smaller than the mean and the median, it's around here, around 57.45, around this part here. The weighted mean is 91.74 and the trimmed mean is 91.45. When we look at these values, we can make some important interpretations. For example, the fact that the mean and the median are very close indicates that the distribution is symmetric. However, the fact that the midpoint is significantly smaller than the other measures suggests that it may have a left skew and some outliers may exist in this variable. And then, when we apply the trimmed mean, we remove the outliers from the distribution. And what we could observe is that the trimmed mean is very close to the mean and the median. And this suggests us that we have outliers indeed in this distribution. We can do the same type of interpretation for the variable temp. As we discussed previously, we have the mean of 18.89, the median 19.30, the midpoint 17.75, weighted mean 21.70, and the trimmed mean 19.09. Here we have some very similar conclusions as we did for our previous variable, which was FFMC, which is the fact that as the mean and the median are very close, this distribution seems to be symmetric. As the midpoint is to the left, this means that we have a left skew. In this case, the distance from the midpoint to the mean and median is small. This means that the left skew is very slight. And finally, the fact that when I remove the extreme points from the calculation of the mean I have a mean, or in this case, I have a trimmed mean that's very similar to the mean and the median, this is an indication that we have outliers as well in this variable. Thank you for watching this class, and see you in our next class about variability measures.